My name is Don Malley. I'm a reporter at Port Technology International, and I'll also be today's moderator in this webinar. And welcome, first and foremost, to this webinar, which is titled, I'm worried about the structure lifetime of my crane. Now what? Which I love. I love that rhetorical question there. This webinar will explore the latest advancements in terminal cranes, particularly crack detection, residual lifetime analysis, and predictive maintenance. I'm very excited today to say that we have three speakers. So we have Olivier Bass, who's the CEO of Villari, who I would consider a leader at the forefront of transforming steel structure maintenance with certified crack detection technology. Next, we have Jacco van der Schans, Managing Director of Console IV, who is spearheading engineering, design, and sustainable solutions to extend the lifespan of critical port equipment. And finally, I'd like to introduce the third and final speaker, Timo Grazen, who's the head of department at Duisport, and his expertise covers crane design, manufacturing, after-sale services, and independent consulting. So, if we're looking at the agenda today, Olivier will start with speaking about Villari's approach to structural health monitoring. Next, Jacco will talk about lifetime assessments by IV consultant. Part 3 would be real-life case at Duisport, which will be conducted by Timo. And then finally would be a panel discussion, which gives the audience and everyone the opportunity to ask any questions that they may like to ask the speakers. So I want to just let everyone know as well, obviously, as you all aware, the chat is active and present. So please make good use of it throughout. And, our job here at Port Technology International is we want to create a safe space where you could interact, enjoy, and engage. So please, when you do make your comments, be respectful and don't say anything inappropriate. Thank you very much. And I would now like to pass on the presentation to Olivier. Thank you.
Yeah, good afternoon, everyone, and thank you so much, Dom, for the introduction. As Dom already said, my name is Olivier Baas. I'm the CEO and founder of Villari. I'm very pleased to be here this afternoon together with two of our valued customers, Jacco from IV and Timo from Duisport. And I'd like to tell you a little bit more about our company and about the technology that we've developed to detect cracks in steel structures, and then how these can be used to extend the lifetime of steel, of cranes and heavily used port equipment. So at a glance, Villari is located in Delft in the Netherlands, and we are monitoring steel assets in 10 countries worldwide. We do more than only port and terminal equipment. We also monitor industrial cranes in steel plants or crane girders. We also monitor lots of bridges, highway and railway bridges. Basically, any type of steel asset that has a chance of fatigue cracking can be monitored by Villari. We have about 1,700 sensors live on assets monitoring right now, and we've been externally certified by DNV. DNV is a Norwegian company that does technology certification, so they really dove into the mechanics of how our system works, in the physics of it, and they approved it, and that really helps to gain, of course, the confidence and the trust of our customers. And our mission is to become the #1 life extension tool for cranes worldwide, and that I'm going to explain to you a little bit more about in the next few slides. So first of all, what is the product that we've developed? Well, there's permanently installed wireless sensors that detect cracks at a very early stage. The first thing that you see here is the green box, which is we call the transmitter. This is a wireless communication module that is battery powered, so it lasts up to 5 years. So after we install it, you don't have to go back to the crane for another 5 years. Connected to that are the sensor strips that I'm going to tell more about later. The box itself is wirelessly connected, as I said before, and it has an IP67 rating, so it can handle quite a bit of bad weather. And it's fastened to the structure with magnets and, if possible, straps. Connected to that box are sensor strips, which are the small things that are on the blue pillar to the left. We have a small one, which is 5 centimeters long, and a long one, which is 50 centimeters long. And these measure changes in the magnetic field of the structure that we translate back to crack growth accurately. Connected to one box, we can do up to 20 sensor probes. So in an ideal situation, you have 20 strips to one sensor. So that means you can cover a lot of distance with one transmitter unit. That information is then uploaded into a dashboard, which I will show you a bit more about, which gives you continuous insight into crack growth or the absence thereof in an online environment, instead of having to go back to your crane once every so often to do an inspection. And I think that's what's the revolutionary thing about our system. So you'll wonder, how does this actually work? Well, it all starts with the Earth magnetic field. We have an Earth magnetic field all around us. Where you sit right now, there's an Earth magnetic field. The beauty of the Earth magnetic field is that it's stable over time. That Earth magnetic field creates a magnetic field inside the steel. So it incites a certain magnetic field inside the steel. You can compare this with a fridge magnet, that it will not attach to your desk because it's made of wood, but it will attach to your fridge because your fridge is made out of steel or iron, which is magnetic. That means there's a certain magnetic field around that absorbs the magnetic field of the Earth. If a crack starts to occur, you will see that locally the magnetic field will start to jump out. This is called leakage of the magnetic field. So if we take a measurement before we had the crack and we take a measurement after we had the crack, we see a change in the permanently available magnetic field. That change is then reported back to the customer through an online environment. Important is that it's purely passive. So that means we don't need to actively magnetize the structure. It's already inside. It's just very weak, but strong enough for us to be able to measure it continuously with our sensors. To give you an example of what that looks like, we have a crack that's been detected in the field. Someone finds a crack which is growing from the left to the right, and the arrow points at the tip of the crack as we can visually observe it in the field. We place a sensor strip next to the expected propagation area of that crack to see if the crack will propagate, while in the meantime the asset owner is considering the repair and planning the repair works. Initially we start to see a deviation in the magnetic field which is still pretty low. But if we continue over time, we'll see that the magnetic field will start to change. These are the three lines we see at the bottom. These three lines coincide with the three zones we see on the strip. If we then go to the next slide, we see that all three zones are now red, which means, okay, something has changed here permanently. And that can be concluded by the 37 millimeters of crack growth, which we spotted visually afterwards. Very important, on the y-axis of this graph, we see the change in magnetic field, and the bigger the change, so from red to yellow, from green to yellow, from yellow to red, the more change we see, the more likelihood you will have of finding a crack. It's pretty straightforward and in that sense intuitive to read. I can give another example. In this case, there is not a crack yet, but it's being placed preventively. This is the most common use case of how our technology is applied by our customers, because in a lot of cases you don't necessarily already have a crack which you want to monitor. In a lot of cases you're putting it on preventively because you want to make sure that it's not cracking, which is something that Jacco will also tell more about in his presentation afterwards. So in this case, we're placing the sensor next to a bolted connection, and initially there's no crack, at least nothing is visually we can see, but there's no crack, so we'll just leave it there and see if there's nothing happening. If we look at the first part of the graph, we do see, however, that from the start, we already have a changing trend on all three of the zones. So we're already getting into that yellow area. Then if we look at the monitoring period over time, we see that on all three zones, we see a very continuous trend over many, many months. We flagged this to the customer and they did inspections, but the customer didn't find anything. They said, look, I'm not seeing a crack, I'm not seeing a crack. It took them until July 2022 to actually see that the crack has grown after taking away the paint and seeing the crack growing underneath from the bolt alongside the strip. As you can see, the crack has grown about 2 centimeters long, but it's pretty far away from the strip, but we could already detect it very early on with our wireless sensor technology. Then, if we take that a little bit further, we also see that in the months after that, our customer felt that the crack could have been stable. They even took a picture to tell us it was stable. But in our data, we still saw a little bit of a trend. We still saw a continuing trend on the sensor data. So we took a good look at their own picture and we say, look, I think there's another 7 millimeters of crack growth. So it might be good to schedule a repair. So after this final report, the customer came back to us and they said, look, we make a repair to this place. So these are two pretty straightforward examples of how our sensor can be used to detect crack growth in steel structures. Now, how is this reported to the customer? For this, we have developed an online dashboard environment. It's basically just a web browser. You can go to dashboard.villari.nl and then you see an online environment where your sensors are located. Now, these could be critical joints or critical locations where the sensors are installed. On the initial picture, you already see the green dots, which are sensors which show no change in the magnetic field, and therefore we don't expect any crack growth to have occurred. If we look at the yellow dots, those show us sensors that might have shown already a little bit of a trend, so there could be some crack growth, initial stages of crack growth near those yellow dots. If we then click on the yellow dot, we will get a close-up picture of the installed sensor, and next to that, we will see the analysis results. So let me explain what we see here. On the right, we see a tubular joint. In this case, this is a pipe section where we have two of the flexible strips all around the circumference of the weld. This means we're continuously measuring almost 1 full meter of weld seam where cracks could grow radially from the inside out. Important, our sensors don't only detect cracks at the surface, but they also detect cracks away from the surface, so subsurfacely. So in this case, cracks are growing underneath the surface, and we can see that at the bottom, the first few zones of the strip are becoming yellow. This means that we have some small initial stages of potential crack growth at the bottom of the tube. That said, the remaining of the strip is still green. So for now, there should not be a reason to directly worry, but we can confirm that there might be initial stages of fatigue growing, and we can see that with the online environment. So if we then click on these yellow zones, on the left we can see the graphs, which we'll see in the dashboard, which will show over time how the data is changing, and thereby we can see that the cracks are growing. And this gives you indeed extra insights. So it can help you say, okay, we see that something is happening, but the detection is continuously. We also see that there's only a few zones yellow, the rest is still green. So the potential total crack length is not much more than 45 millimeters. For now, it might be best to not worry too much, but let's keep a good eye on it. And I think this is how the sensor can provide a really good tool in analyzing what actions to take when, instead of just doing an inspection once every so often, and also being sometimes surprised, maybe either surprised by that nothing has grown, and therefore the fatigue is maybe not as heavy or as worrisome as you might consider initially, or being surprised negatively in a way that you'll find cracks which grow much faster than you expected, and you might need to shut down your crane for a while to do an emergency repair. All these things you can avoid by getting continuous insights and by monitoring your assets with wireless sensor systems. This was the presentation. I've tried to keep it a bit short and explanatory initially, so I'm really happy to take a few questions. Could be from any sorts of questions that you'll have. So I'll give the word to Dom.
Thank you very much, Olivier. As Olivier said, if you would like to ask him any questions, please put them in the chat. Oh, straight away already, you're making my job easy, guys. So Stelos, he's asked, what magnetic technology do you use, brackets, what kind of sensors are used?
Yes. So first of all, these are AMR or anisotropic magnetoresistant sensors. So they're basically the same type of sensor that are used in your mobile phone as a compass. So it's like a sensor that measures the magnetic field in three components, X, Y, and Z directions at the location of the structure. So it's in that sense, somewhat straightforward standard electronics that we use there are plenty used in mobile phones or in cars or whatever to do positioning. So it's standard positioning type AMRs.
Brilliant. And next, I see you have 3 questions there, Stelos, but we're going to give other people the opportunity to ask, but thank you for them. We've got one from David Shaw asking, how far from the sensors can the system detect a crack?
Yeah, it's a good question. So we have a certified detection range of 30 millimeters diameter, 3-dimensional around the sensor. So that's in 3 directions of volume. We can detect cracks that are already 5 to 10 millimeters long and 1 or 2 in depth. So within 50 millimeter, we can detect very tiny cracks. I would say comparable with ultrasonic inspections, phased array inspections, or time of flight diffraction. If the cracks are a bit further away, so let's say 20, 25, 30 millimeters, we will still be able to pick it up, but it might take a bit longer. So the crack might already be a few centimeters long. So that's roughly the ballpark figures that you have to think about.
Excellent. We've got another one here from Nick Applegarth. What do you use for connectivity, brackets, Bluetooth, 4G, or Wi-Fi?
Yeah, great question. We use LoRaWAN, which is a wireless type of network, which is different from these one in the sense that it uses very little power and has a very long range. So for a typical terminal, you will need one gateway, which is a separate standalone device, which does not connect to local networks. All it needs is a power plug. It creates a network, and from there we can get the data from the sensors and send it over 2G, 4G to our clouds. It's very important to understand it's a standalone system, but we do need a router to send the data. Typically, because it's standalone, IT departments are okay with it, but it's important to understand. Yeah.
Excellent.
Maybe, sorry, Dom, maybe sorry, Don.
Go
The
ahead.
second question from Stelios Disciples is also pretty interesting. The sensors, do they measure cracks or stress fields? And that's a very important one because they don't only measure cracks or geometric changes, they also measure changes in stress, so plasticity. So it also works to detect plasticity, and that's why we also pick up cracks so early, because with all the other technologies like ultrasonics, you will have to wait for an actual geometric defect to appear, whereas our sensor already picks up that plasticity around the crack tip before it becomes a big crack, and that's exactly why our sensors are already picking up crack growth in a very early stage.
Very informative, Olivia, very informative. We've got another one here by Lindsay. Can this tech be used? I've got another question, that's why I came off. Can this tech be used on structures other than cranes, berthing dolphins on Rome terminals, for example?
Well, that's a good question. So it can be used on any, ferromagnetic steel structure, which can show sign of cracks, which is relatively stable. So if it's made out of steel, and that's typically construction steel, then it's magnetic, and then it can be used. So that's typical. So that's why we do bridges and cranes, etc. I have to say I'm not an expert on berthing dolphins, but maybe Jacco can answer that one actually.
Yeah, it's exactly what you said. I mean, every fatigue loaded structure can be applied with these kind of sensors.
Yeah,
and it looks great. Yeah.
Okay, brilliant. We've got another question here from David Shaw. It says, if a crack exists when the sensor is first placed, will it detect it?
Yes, it will detect growth. So it's a very important thing is that our sensor takes a baseline reading of the magnetic field when you put it on, and it will check every few hours if that magnetic field is the same. So if you have a big crack and we put it on and the crack is not growing, our sensors will show green. It's fine. So it's very important to understand that our sensors are very good at showing changes over time, but they are not suitable for detecting cracks as is. So it's very best used in combination with, let's say, an inspection. So you do an inspection of your welds, you have your baseline reading, then you put the sensor on, and then you are good to go. So it's really important to understand if a crack already exists, sure, it will pick up growth, but it won't detect what's already there.
Very clear, very clear. And I think we have time for one more, and I'm going to do Mansour Khurshid. Did I get it right? This system can detect cracks in depth, i.e. invisible. Welds usually have small defects. How does the system work for welds?
Yes, I think a very, very good question. So indeed, we also detect cracks subsurfacely, and I think that's also what makes the system really, really good. We also can detect it through the paint, so you can leave the conservation on your structure. The paint you can leave on, you can put it on top. You will also detect cracks subsurface, so yes. Indeed, welds usually have small defects. This is why our system was designed with longitudinal strips to cover welded areas typically, because that's where cracks typically start from these little deformations. So it was designed for these. Well, the answer would be it works for welds where there are small defects. You put it on. If the small defects remain small defects, if they don't grow, our system will show green, which means, yeah, there's maybe a defect, but it doesn't grow, so it's maybe not worrisome. If the small defects turn into cracks, or they start to grow, or they start to get plastic deformation in the steel, that's when the sensor picks it up. So yeah, this is exactly what it is designed for.
Excellent, excellent. I know, David, you're dying to know Stelios' question-free answer, but we do have to move on. And I do want to remind everyone that there will be a panel discussion at the end where, again, we can come back and revisit some of these questions.
But maybe it's good because that third question is actually, that's straight up for Jacco. So I think that's a question.
Go ahead to set him up.
No, but Jacco will present this in his part, I think, how to translate this to remaining lifetime, because that's not what Villari is good at. That's really what IV are champions at. So I'll give.
There we go. Okay, so ladies and gentlemen, our first speaker, Olivia Bass, the CEO of Villari. Thank you so much, Olivia. And we are now going to go to the next segment, which is Jacco van der Schaan, who is the managing director of Consult IV, and this will now be part 2 of the webinar.
Yeah, thanks, Tom. Like you already said, my name is Jacco. I'm the managing director of IV Consult, and I will introduce the IV group very quickly. So as you can see, IV Consult is part of the IV group, and altogether we have about 1,300 employees, mostly engineers. So we can be a one-stop shop for everyone in need of engineering. And IV Consult then is specialized on structural and mechanical engineering. So the structural team does a lot of onshore jobs like buildings, skid buildings, everything that has to do with steel constructions, but also with concrete or wood or whatever. And we do a lot of offshore engineering, so the design of topsides, but also lifting plans and transportations. And then we have a mechanical team that is specialized in developing tools, so heave compensation tools or specials, or floating solar farms, that kind of stuff we do on a regular basis. And now it gets interesting because we also have a team which is specialized in cranes. And as you can see in the picture in the top left corner, those are ship-to-shore cranes. And years ago, we acquired the engineering department from Kalmar Cranes in the Netherlands. And those people are still working with us. And ever since we took over their engineering department, we did all the structural and mechanical engineering for every crane that they sold. So I think we did about 20 cranes in total. Nowadays, we are still involved in those types of cranes, and what we do now is procurement assistance when a terminal wants to buy new cranes, but also advices on problem solving or heightening of the crane or lengthening of the booms, that kind of stuff. So we're still with a pretty big team involved on cranes like that. But we also develop offshore cranes, like you see in the top right corner, ringer cranes, and we do quite a lot of measurements. So zooming in on those STS cranes, as you all guys, as everyone knows, it's a pretty expensive asset, right? On the last jobs we did as a procurement assistant, we found out it usually ends up between 12 million euros up till 20 million euros per crane, and you buy it in a series. It's quite a big investment, and those cranes are key for a smooth operation of your terminal, of course. And most terminals have a crane driver on the crane and people walking around on the terminal. So it better be a safe piece of equipment as well. And that gets more and more difficult to guarantee at the end of the lifetime of a ship-to-shore crane. And on top of that, when you want to buy new cranes, there is a carbon dioxide footprint involved, and some governments in Europe are giving you a hard time on that as well. So luckily enough, our team is specialized in extending the lifetime of fatigue-loaded structures such as container cranes. We don't have a lot of time to dive in too deep, but let me tell you this. On the left side, you see a graph in which you can see the relation between the number of stress variations and the number of cycles. And every detail, so every well type and every bolt type has a number of load cycles that it can handle, and after that it will be the end of lifetime for that detail. And then on the right graph you can see a comparison between the old code, the FEM 1001, and most cranes that are up and running at this point are designed according to the FEM 1001, and that's an older code which is more conservative and only has a couple of notch factors taken into account. And you can see that the new code, the green one, the Eurocode 13001, has far more notch factors and has more nuanceation in it. So already by applying a new code, we can find some extra lifetime in some of the details. And we know where to look at. So that comes in handy, but it's not enough yet. So when clients are asking us, okay, can you do a lifetime assessment of my crane because I want to use it an extra 5, 6, 7 years, then we have a standard step-by-step approach that we are using. So we always start with collecting the input. That's the original drawings and the calculations, but also we need to know about the adjustments that were done to the crane in the last years. And also we need to have a log of the cycles and container weights. And sometimes the terminal doesn't have it available, but with our experience, we can do a very educated guess on that one. Next thing, we start modeling the crane in our FEM models, and we put in a load spectrum. And again, sometimes the client don't really knows about how the load spectrum would look like for his cranes. But when we look at how the terminal is being operated, we can make a pretty educated guess about that one as well. And then the next thing is to do the analysis itself. So on the right picture, you can see that whenever we suspect there is a detail important enough to zoom in on, then we make a cutout detail, and we can zoom in a bit further, and then we can list all the problem areas that there are in the crane. After that, we like to go on the crane and do some inspections together with the asset owner. And then the last point, that's where it gets interesting, because in the old days we only had two options to advise our clients. It's either a structural adjustment to the crane, or you should do frequent inspections in NDT. But both options are not perfect, because doing structural adjustments on a crane, that will it will bring them out of service for a while, right? And you need to do welds on site, and that's always hard to make a high quality weld on site. So don't really like that option. Then the second one, frequent inspections and NDT. Sure, you can do that, but the frequency in which you need to do it depends more or less on how safe the equipment is, and how quick a crack would grow, and that kind of stuff. So if it's once a year, sure, but if it's more frequent, then it gets a very expensive method. Especially when the details you want to NDT are not easily accessible. So therefore, I'm really happy that Olivier and I get into touch years ago, and we are now buying the Villari sensors and putting them on the cranes that we inspected for the lifetime assessments, and that really helps. So we have this monitoring approach. So we did a lifetime assessment, and then we start making a sensor plan. And we usually coordinate together with the asset owner, because it depends a bit on how many risks you want to cover. Because we can make a sensor plan depending on three items. It's either the fatigue life of a certain connection, a certain weld, but it also can be wise to monitor a weld which is high in its unity check. And also there is a thing, how critical is the connection. So you can say, okay, it's not that bad fatigue-wise, but if the weld fails, then it's a disaster for the crane. So and let me remind you, the fatigue analysis is a lot of theory, but you're also depending on the actual quality of the weld. So that's our sensor plan, and we coordinate together with the client how many sensors for his risks. And then the next thing is that we can do an extrapolation. So for example, usually the SDS cranes are built in a series. So an asset, a terminal owns like 5 the same cranes, and we can provide a lot of sensors on one crane and do some extrapolation on the other cranes. And then still we can give him an advice. So at this point, we have like 700 sensors up and running for a couple of years now, and we're pretty happy with it. And we can give real-time advice to our clients, because sometimes a crack occurs, and we know by the model and by the calculations how fast the crack will grow and how dangerous it would be if it continues to grow. And sometimes it's not that dangerous at all. So we can just say to the client, okay, take your time, but in the upcoming 3 weeks or 3 months, if you have a moment to spare, you can start thinking about doing some repairs. But in other occasions, it might happen that we have to call the client and tell him to shut down the crane because it's too dangerous to continue working with it. So, and it's something in between those two options, of course. So far we have a very good experience with the Villari sensors, and like I told you in previous slides, we are also working with offshore tools. And we're looking into the options of having those sensors on our offshore toolings as well. Yeah, it's pretty interesting. I will make sure to put a link in the chat to our website, which is also connected to the Villari website again. But if you have questions now, then feel free to ask me.
Exactly what Jaco said. If you have any questions for him, please feel free to get involved and ask. And please, I want to just say, guys, if you do have any questions, there is a question section where you can actually directly ask questions just so we could keep up with the questions more easily and they don't get lost in the chat, just in case I miss it. But yes, any questions, guys? Let us know. Anyone? Well, I've got a question, Jaco. I want to ask, how many years can you add to the lifetime of a crane?
Yeah, depends a bit on the how it's being used and how conservative the original design was made. But what we see now is that usually we can stretch the lifetime with 4 till 7 years, something like that. That's very realistic.
Okay. It looks like we've got a question here from Abdisalam. How much time does the investigation take, and what are estimated costs?
Yeah, so usually our lifetime assessment takes, I think it is somewhere. Yeah, it depends a bit on how much variations do you have between the cranes in the series. We done some smaller cranes, then it's 1 month, and we done some bigger STS cranes, then it's more like 2 months, something like that. And then the estimated cost is also part of his question. For the bigger cranes, we end up around 40,000 euros.
40,000. Okay. We've got another question here from Robert Wellak. Are the crane spreaders also involved?
Yeah, sure. Actually, everything that's made out of steel can be monitored. And crane spreaders is actually something we run into on a regular basis. Yeah, absolutely.
Okay, brilliant. I can see people typing for some more questions. Guys, I do just want to say again, please can we use the questions tabs just so it's clearer when the questions are coming through and I'll be able to navigate them more easily. But anyway, in the meantime, Mansour asked, which standard do you follow for calculations?
Yeah, that's a good question. Yeah, the new Eurocode 13001 is pretty sophisticated, and we like that one. Yeah, but we can use all the other codes as well.
Okay. And then we've got one here from Marcelo. Do you know if in the US, do we have any regulatory safety compliance required that we need to have this type of inspections for the STS crane?
I don't know particularly about the US, but yeah, well, you should guarantee safe equipment to work with to your personnel, I would say. First start, whether it's in the law or not. I think that's something every terminal should think about. And I know other countries in Europe do have such regulations, but how it's exactly in the US, I don't know exactly.
Okay. We've got another one here from Alvis. What type of signals is getting from sensor?
Yeah, I think it's better if Olivier answers that one.
Yeah, sure. So the sensor measures magnetic fields on multiple locations. So there's multiple data points of the magnetic field, and those are translated raw or sent raw by the transmitter over LoRaWAN. So it's measuring raw magnetic fields, and then we do in our office we do the analysis to make sure that we get those graphs out, which tell you about the correct road. The sensor itself sends ferromagnetic field information. So yeah, that's what the sensor measures.
Okay, have we got any more here? Let's have a look. So we've got one here. It says, is this system/sensor applicable for all types of cranes?
Yeah, pretty much. Yeah, every tool that is fatigue loaded can be monitored with those type of sensors. Yeah.
Okay. And then we have another here, which is from Mansour. It says EN13001. You showed is less conservative compared to FEM1001. Do you take into account which standard equipment manufacturers followed?
Yeah, so there is a design code indeed, and there is a quality code on those cranes. But from a calculation point of view, there is some more conservatism in the FEM 1001 code because it's an older code and it's only logical, and back then the computer power was less than what we have right now. So more investigation has been done about the fatigue and notch factors. So yeah, that's why they made it a bit more sophisticated.
Okay, brilliant. We've still got time for a few more questions, guys, so keep them coming. We would be very interested to hear what you guys have to ask. Anyone? We've got another one here. How do you determine the best locations for the sensors?
Yeah, it's usually based on 3 points. So it's either peak-wise, it's the end of life for that detail, or it's a very critical point. So it's important to monitor it, because if it fails, then the brain would collapse or something like that. And the third point can be that the unit check in the original calculation was very high. And then when there is a less quality weld involved, then it might be advisable to monitor. Yeah.
Okay, brilliant. Brilliant. I think that concludes this section of the webinar. So thank you very much, Jacco. You've been excellent. And next we have Timo Brazen, who's the head department of Duisport. So this is part 3 of today's webinar, guys. Take it away, Timo.
Yeah, thank you very much. Thank you for the introduction. Welcome everybody from the Port of Duisburg, from the crane department. The Port of Duisburg is well known as the biggest inland port of Europe or the world, depends on whom you ask and you give the answer. It's probably worth to mention that the port is not just one location at Duisburg, but it's spread all over the city, and we have probably more than 1,500 hectares of space where we do our operation. Focusing on cranes, so there are more than 130 facilities where we operate with cranes. Most of them are overhead cranes in kind of terminals or factories or warehouses. And that's for me, that's the interesting part. We also operate 9 container terminals inside Duisburg with more than 20 rail-mounted gantries all over the city, and handling more than 4 million TEUs a year, which is half the amount of Port of Hamburg, just to give a comparison to that. The headline of this seminar is, I'm worried about the structural life of my crane, what now? And I was confronted with this question quite early when I came to Duisport, because we have 2 cranes and I'm really worried about them, and I just want to share some experience with them. The picture of the cranes, both of them are operating in a terminal in the southwest of Duisburg. It's a rail-to-road terminal operating in 24/7 operation, so it's quite heavy loaded. Those cranes are not that old, so we have cranes operating in Duisburg. They're more than 100 years old, and those are only 10 years old, but still making some big trouble. We take care about them, doing weekly inspections and maintenance on it. We do our annual safety inspections. We also decided to do 3 yearly inspections on the steelwork, just to guarantee the safety of the crane. So what happened in year 2 of the lifetime of this crane? Nearly the whole trolley came down because there was a serious big crack, right close to the slewing gear. That made us all a bit nervous. If you step back, you see 2 really big cranes, but you also see a very stiff structure, a very massive steelwork. And it's, for me, when I firstly saw those cranes, I thought, no, they are rigid and they will last forever. So what went wrong? And I just want to take you a bit within the story of those 2 cranes. And Jacco, I hope you apologize, but I will do it the theory in a very simple level, yeah, and just as an operator things. So when it came to buy those cranes, we thought, 25 years, that's a good lifetime for a crane, and we don't want to worry about those cranes for maybe 24.5 years and then think about something else. And when I thought about what that meant to me, I wanted to have some kind of reliability. I wanted to have a safe crane for lifetime. So we bought a crane that should last for 25 years. When we came to the manufacturer, he didn't find a standard to type in 25 years. So what he did, he calculated the crane for a certain amount of cycles. There's a huge discussion about what is a cycle, but anyway, we'll leave it away. It's something between 600,000 cycles and 2 million cycles. That means 25 years can be somewhere in between, depending on how you operate this crane. And from that, what we thought when we bought this crane, there's far a great distance between. So we hope to get a crane with eternal lifetime. We bought a crane with 25 years, and we got a crane that could make serious damage after 600,000 cycles. That is, so far I understood from my studies and everything, that was quite clear. But when I looked into history of those two cranes, I saw that even before the crane were elected, before they did their first container move, some things happened that had a great influence on the lifetime of those cranes. So we later found out that there were some serious failures and mistakes in the calculation. For instance, the static guy had taken the weight of the crane into account, which was only half of the weight of the real crane. The design had several lacks when it came to fatigue-loaded junctions, where they took the wrong welding designs. The manufacturer did some mistakes when he did wrong weldings and not the proper weldings. Some weldings were even left away. We found greasing holes. They ended somewhere not in the bearing, but somewhere in between. We found several failures done by the erection of the crane, so the wheels are not in a line, and that causes some kind of not equal driving of this crane. So even when we bought this crane and when the crane was erected on site, the lifetime of the crane was really influenced and not to the good side. And today I want to focus on the chassis and on the main bogies, and you can draw a similar draft to every part of the crane if you want. But I just want to tell you what happened when we operated the crane. So the electric design of the crane was also not that proper, and there were some failures in the software. They lead to a serious accident in year 2 of the crane. Both of the cranes drove against each other and they hit each other, and that caused initial cracks on the drive bogies. And the lifetime of the crane went down from 1 second to the other. When I remember the time when I was designing cranes, I've never taken such things into account, but they happen as life goes by. There was some of the greasing nipples were missing, and the wheels were not in line. The wear increased incredibly high and caused additional stress to the structure. So in year 8 or 9, we found first cracks at the drive unit and the chassis. And that all led to the questions, how safe is my crane now? So we could see there are cracks and what to do with that. And from that point, it's not only a question of lifetime and of reliability, but it's a question of safety. So my manager asked me, Timo, what shall we do? Do we need to close the terminal because both cranes were infected? Or can we still operate the crane? And that was a really, really critical question I didn't have an answer on. Just a few pictures. The crane is built, or it's based on 4 corners, and 4 corners, every corner has a separate chassis, drive unit containing 8 wheels. 2 wheels are mounted in 1 bogie, and then there's a middle swing and the main swing. We found those cracks in the junction between the main swing and the middle swings. So there are 2 pins at each main swing, means we have 4 points per swing. For 2 cranes with 4 corners, that makes 32 critical points where we found cracks or initial cracks or even nothing. And we, if you look on the picture in the middle, you can find a detailed photo. It's from downside up, and you see the junction, that there is a lash coming down from the main swing of the crane, and in the middle swing there's a pipe welded to the box girder of the middle swing. We found those cracks in the weld in between. It's just a fillet weld, so not a weld proper for dynamic forces in this area. And the question was how to deal with that. it's quite difficult to access for repairers, and so we decided to monitor those cracks manually. That meant we send a guy there every day and later every week and so on. But depending on who went there and who reported, he saw something different. And that was really a bit difficult to deal with. We were glad that this position is quite easy accessible. You can walk there simply, and you don't need to take the crane out of operation or build something to get there. But anyway, that wasn't a really good solution. And it was to that time when I met Villari, we decided to try their system. That wasn't a high risk for us. So we had some cracks. We knew the crane is in bad conditions, and it was easy accessible. And I'm quite glad about the solution they provided. This is the installation of the sensor straps, and we agreed on 4 sensors per connection. They are all gathered together in one box. There's one LoRa network on the terminal now. And as you can see in the dashboard on the right hand, those areas are marked with green dots. It's even easy for a managing director to understand how the system works. So green is everything is fine, or there's no change to when we placed the stripes. Suddenly, 1 month ago, 2 of those sensors turned into yellow. That means we noticed some cracks. It's going forward, something is moving over there, and finally they turned into red. But with those sensor types, we were able to really say to every time of the day how safe my crane is. And we were able to say, no, there is a crack going on. We went there and repaired this crack. And now we're about to reinstall the sensors, and we can run this crane, although we know there are cracks, because we see if the cracks are growing to a critical side, and it gives us some time for some more things to invest and to take further action to get rid of those cracks. And this was maybe a quick insight from one of our cranes. We installed the sensors at.
Okay, so we are now in the Q&A part for Timo. If anyone has any questions, got a long one here. We've got one from Stephen. What about the electrical architecture? This can have a massive impact on the cranes and the life cycle and mechanical organs with premature wear. A good example is premature wear on the gantry traveling movement or operation stoppage of each movement, such as on a large hoist movement in the respect to 13.849.1.
Yeah, that's a really big story. When the crane is designed, you don't talk about that, but a really little failure in the electric steering, which becomes more complex from day to day, that can cause really big trouble, and you can cause cracks and loads in the steel structure nobody takes into account. So I'm sometimes a bit worried about how easily our software architects change their software without taking into account what kind of impact that may have on the lifetime of the crane. So it's really, really, really important to work together with them and to make sure that nothing happens that can cause really big trouble to the lifetime. Yeah, of course. So the accident I mentioned in year 2 or 3 of the crane, that was caused by a lag in the software.
Absolutely. And we've got another question here for you, Timo, which is, why did you not repair the cracks immediately?
Yeah, that was my answer to Oliver when we met. I don't want any sensor. I don't want to have cracks, and I want to get rid of them as far as I can. But in this case, we couldn't, because a proper repair means we had to unmount the whole chassis of the crane, and that was cause a massive stillstand. We are about to replace all those infected steelworks, but this is a very big thing to do, and we couldn't do it so quickly. So this is why we had to monitor those sensors. of course, as a responsible person for cranes, I don't want to see any cracks. Yeah.
So we have another question here from Caroline, which is, what is the lifespan of these sensors and how do you know when to replace them?
I think this is a question to Oliver, but
yes,
it's about 5 years. Yeah.
Thanks. I will answer that. Maybe I'll first reply a little bit to your final comment, and I think that's maybe to put it in perspective. This is an interesting use case of monitoring existing cracks, bridging, let's say, that last bit of lifetime until the replacement comes. The majority of our sensors are placed in locations, as also previously discussed, preventively on places where there are no cracks or maybe tiny indications to know how the crane is lasting. Ideally, you don't have a lot of cracks in your crane, but sometimes it just happens that you find something and you get into a situation, as Timo presented, that you have to have some kind of temporary solution, that you want to have the certainty and safety that it's not progressing further. I think that's where we help out. When talking about the sensors, we try to design them as much as fit or forget as possible. You put them on once and you can leave them there. The new design lasts for battery guaranteed 5 years. And then we can just swap a battery, and then the electronics themselves can last for 10. So with one battery swap, we could go for 10 years. And I think for a lot of cranes that are end of life, 10 years would be sufficient. As Jacco mentioned, you might get 4 or 7 years out of your crane extra. So I think we should be good there. So that's a good thing to know. Once you put them on, you really don't have to go back for any maintenance.
Absolutely. We've got another question here for you, Timo, which is, how long did the installation of the sensors extend the lifetime of your cranes?
This is a bit difficult to answer. Oliver, please don't beat me, but I will say nothing. So going to a doctor doesn't extend your lifetime, yeah? But you know about your status, and that was the thing for me. So my question was not to extend the lifetime, but to guarantee a safe operation. And for that, I truly knew that cracks are growing or not, and I knew an answer, and I can give this answer day and night, because there's an online system, and I can see how the cracks are moving and continuing. And another thing is, I know exactly on which areas I have to focus to. So there are 32 areas in a similar way, but only 7 or 8 of them making trouble. And I know if the others start making trouble or not. So it's not, in this case, it was not an extension of lifetime. It was just to be sure where I am in my lifetime, to get rid of this question mark as shown in the graph.
Okay, so another question I have for you, Timo, was it difficult to decide where to place the sensors?
In this case, it wasn't really difficult because we knew where the cracks are or where they would appear. So we decided together with Villari to place sensors at the end of the cracks, of the known cracks. And where there are no cracks, we decided to place them in the main area of the force, so underneath the pin. And that was quite a good working together with the experts from Villari. It took a couple of hours to decide where to put them. Yeah? That was quite well, yeah.
Maybe it's good to add, if I can add a bit to that, Dom. I think indeed, if you have really already clearly identified cracks, we can work together with the S-Donor to think about extension of the cracks and where the sensor will be placed. If you're really thinking about the preventive placement and the lifetime extension, and it's really important to add engineering into that mix. And I think that's also why IV is here, to really think about that placement. And then it becomes more complex, as Jacco already explained.
Absolutely. And I've got another question here for you, Timo. How long did it take to deliver and install these sensors?
How long did it take? Yeah, that was a question of hours, I think. I think it took longer for our purchase department to add Villari as a new deliverer than for Villari to ship those sensors, as they reacted very quick. I think overall it took 1 week, but from the installation till we got the first results, I think that was maybe a time of 2 weeks. because those sensors have to learn at first. Maybe Oliver can comment this as well. But I think from the decision to buy those sensors till we got the first results, I think there was about 3 weeks, maybe one month in our case.
Yes, I'll quickly add. Indeed, when the sensors are installed, as I explained briefly before, we take a reading of the magnetic field as it is, and we see if it grows over time. That requires us to take a baseline measurement first. So we have to see the behavior of the crane. That affects also those readings a little bit. So we typically take 2 weeks of calibration period, after which we start to measure changes. So there's a little initial period where after installation, we need to wait before we have enough data to get a full continuous monitoring going on.
Brilliant. Have we got time for any more questions, guys? Do you guys have any more questions that you'd like to add? Please let me know. We're very curious, and we want to hear what everyone has to say. Anyone? So we've got one here from Marcelo Timo. Did you need an outside team of risk assessment specialists to make the decision as to what was the best course of action to take and move forward from the safety standpoint?
Yeah, of course we did. I work as a crane inspector, so I'm some kind of expert. I trust in myself to do that, but I also get in contact with other persons dealing with that, because that was really a big issue when the managing director of Duisport asked me, can we operate the crane or not? So I wouldn't rely on myself in this case. I think it's good to have a team around you and a team of experts to talk about too. And this is what we did, and I really appreciate that. Maybe we, especially as a man, we are used to do everything on our own, but in this case, it's very important to work together and to gather the information and the experience of all kinds of experts, Yeah.
Brilliant. We've got another one here from Kevin Walker. What is the initial setup cost for a full complete complement of sensor cranes per STS crane? Excuse me. Does Villari monitor changes?
Yeah, in my experience, it depends also a bit on how many sensors do you need on the crane. So if it's just 1, 2, 3, or 4, then it's another price range than when we have 50 sensors on one crane. And also depends on the location. Is it hard to reach, or can we have access just from the ground? So there's just too many factors involved on that one. So we need to know a bit more about the location of the sensors and the location of the crane.
Okay, so we are now going to move on to the last part of today's webinar, which is the panel discussion, which gives everyone the opportunity to ask all 3 of our speakers today any further questions that they may have. I do recall that there were some asked earlier, so I will touch on those. And I remember one of them being, do you determine the remaining lifetime and how? If any of you gentlemen would care to answer or feel comfortable answering, feel free to.
Yeah. So usually we do a lifetime assessment on the cranes, right? And we have a log of all the cycles that it was made during its lifetime. But also we want to know about the accidents, snag loads, that kind of stuff, or other accidents and other repairs. So every load cycle builds up a bit of damage in every weld. And the combination of all those build-up damage, that determines how many lifetime there is left in every connection. So yeah, sure, we did determine what's the remaining lifetime of every important connection. And by then, we can determine where to put those sensors and where not.
But Jaco, I would like to add, this is a discussion, open discussion. It's quite difficult to give a precisely answer on this there's always some kind of risk that you didn't get it right because you don't know everything about it, and there's still a risk and still the responsibility of the operator to do inspections and so on.
Absolutely. Yeah, that's absolutely right. And it's also, like I said in my part of the presentation, there is always a risk left for the terminal. So you need to determine, okay, how much risk do I want to absorb, and how much do I spend on sensoring and on monitoring. And some loads, like snack loads and that kind of stuff, it's really hard to determine what the damage buildup was. And usually it doesn't happen that often, so that's luckily enough. But indeed, that's a bit of a gray area, and we can do some estimated guesses about that one. But still, there is a risk left in the equation, absolutely.
Yeah, I'd like to add to that I do agree with Timo that our sensors are not directly increasing the lifetime of your asset. I think the combination of engineering and sensoring is just giving you a lot more information that you can use to make a decision. And that continuous flow of data combined with engineering can make you in a very different position to decide what to do with your asset compared to maybe traditionally having a look once in a while. I think that's the key differentiator here. But indeed, we're not technically making the crane stronger or anything. It's just getting more knowledge out there.
So the next generation of your sensor should be able to weld those cracks, shouldn't it?
We'll glue them so tightly that they'll never crack anymore.
Brilliant answer from all three of you gentlemen. So we've got the next question here, which is, who handles the installation of the sensors?
Well, when we do a lifetime assessment, we are the main contractor, and we take care of the installation. So we usually use a subcontractor or do it ourselves, and usually we do it together with Villari. But perhaps at Duisport that goes a bit different, I don't know.
Yeah, we did it together with Duisport. It depends really on the accessibility and the locations, and if you need rope access or anything. But yeah, we can take care of it indeed with subcontractors typically. Yeah.
Yeah, this may be a practical things to add. I was surprised. We ordered about, I think, 64 sensors for the whole for two cranes, and I was surprised it took only maybe half a day to install all of them. So it was really a quick installation and very, very smooth. Yeah.
Yeah,
but
indeed.
it was done
5 minutes. Yeah, 5 to 10 minutes for each box. So indeed, it's really quick. The big part is usually getting there, and in that case, your cranes are very easily accessible. I think with Jacco, we also have experience on more complex to reach locations on cranes, and then it's the accessibility which is usually the hard part, not the gluing itself. Yeah.
Brilliant, gentlemen, brilliant. With another question here is, what is the biggest drawback of using these sensors compared to traditional methods?
That's a very good question. I think the biggest drawback is also the question is also earlier asked, is that we don't measure what's already there. It would be great if you would put it on and would tell you exactly what kind of subsurface defects are there, or what's already in there when you put it on, so you don't have to inspect anymore. And unfortunately, it's just not suitable for that. So the biggest drawback of using the system is, first of all, that you only monitor changes, so we don't know what's already there. You could argue that if you only know if it changes or not, that's enough, but it's still good to know what your baseline is. So that's I think, a big drawback. And the second is that even though it gives very high quality information, it's very local. As I said, we have a 3 centimeter diameter around the strip, which is nice. We can also see subsurface cracks, but you have to know where to put them. So you have to do some engineering, or you have to already find a crack, like we had the Timo's case, to know where to put them. It's not like, you can just randomly put it somewhere and then you're good to go. So I think you have to really think properly about how they're being placed together with an engineering company, which is, I think, in some sense a drawback. Yeah.
Yeah, I'd like to add a bit. It's not a drawback of the sensors, but of the thinking. Maybe if you install those sensors to critical areas, you still need to take into account that you only install this to critical areas and not to others. So in our case, we still need to monitor the other parts of the crane. And it may a crack may occur a meter beside the crack, the sensor, and we won't get notice of it because we think we are safe because we have those sensor systems. You still need to know very clearly what you do. And this sensor systems give you really good help for the areas you put them to. So it may be some kind of false safety if you just install them to some areas and leave away the others. So I noticed that on me personally, I still need to do my inspection, and the year goes by and I didn't do it. So I need to hurry.
Yeah, good point. You have to keep thinking indeed, and keep being aware that it's an aging asset and that requires a bit more attention. They'll just put sensors on and then leave it. That's a good point.
So we have another question here, gentleman from Alvis Wilson. What is the make and model of sensor and receiver?
So they are custom designed. So they are designed by Villari and then deployed by us. So they're made in Europe, and it's our product. So I can send specifications after, but I think that's what we can do. Yeah.
Okay, brilliant. We've got another one here from Marcel.
Sorry, it's maybe important. It's not an off-the-shelf type of sensor. It's a specific sensor we designed for this specific purpose, and we're the only ones that develop and deploy these.
Excellent. So there's another question here from Marcelo Olivia Roberts is, what is the approximate average cost of these lifetime assessments? Also, what is the estimated time frame for their completion, considering they are being conducted outside of Europe, such as in the USA?
Yeah, for the lifetime assessment, it depends a bit on how complex the crane is. If it's a small automated stacking crane, then it can be quite quickly, 1 month. And if it's a complete ship-to-shore crane with dual hoist mechanisms and with extra trolleys on it, then it takes 2 months or so. And the average costs end up around 40,000 euros for a big crane, for a STS crane.
Okay, brilliant. Have we got any more questions in the chat? Please feel free to. Our 3 excellent speakers are all here and ready at your disposal. So if you have any questions for them, please feel free to share. You're all free for being here. So everyone, that concludes today's webinar. I'm worried about the structure lifetime of my crane. Now what? I'd like to extend my sincere thanks to our speakers, Olivier, Jacko, and Timo, for their insightful and informative presentations. Thank you for all the attendees for joining. We hope that you found today's session very valuable. Just to remind you all that this webinar will be on demand, so if you are interested in accessing this content after, please feel free to. And all I have to say now is that I wish you all a great day, and we'll be looking forward to hosting another webinar and hopefully seeing you back. Thank you all very much.